Jai Hind everyone. My name is Anupam Kumar Saini, Assistant Professor, IT Department, AKGEC, Ghaziabad. Today I discuss minimization of DFA. There are various methods for minimization of DFA. One of the best methods is Myhill-Nerod theorem, that is also known as table filling method. In this method, we design a table for every pair of states and fill the entries in that table with the help of DFA provided. For this minimization method, input is DFA and we as an output we get minimized DFA. There are four basic steps for finding Myhill-Nerod theorem. Step 1, draw a table for pair of state PQ not necessarily connected directly. And step 2 is the main step. Consider every state of pair in the DFA where one state should belong to final state and one state should not belong to final state, or vice versa. As written here, P belongs to final state and Q not belongs to final state, where F represent final state and P and Q represent as a state. And step 3, if there is an unmarked pair PQ such that mark it if pair transition PX and QX is marked for some input alphabet X, then mark P and Q. Combine all the unmarked pair PQ and make them a single state in reduced DFA. These are the basic 4 steps we explain with the diagram. Now, this is the question for in which minimized with the help of Myhill-Nerod theorem. In this DFA, there are 6 states Q0, Q1, Q2, Q3, Q4 and Q5. These are the 6 states in DFA. Now, construct a table for these states, means we design a matrix of 6 cross 6. This is a matrix Q0 to Q5, Q0 to Q5. We take only the states where Q0 one state should not, we consider that state only that will not repeat in this diagram. So here I marked in 2 colors, red color and green color. In red color we see that the state will repeat as green color. This state is combination of Q1 Q0 and this is also combination of Q0 Q1. Same Q2 Q1 and this is Q2 Q1, means these states will repeat. So we take only one state. So we consider only green part and we neglect these portion because all state repeating here, not matters which state will come first and which is second. So this one is a Q0 Q0, Q1 Q1 and Q5 Q5, same state. So we remove this in our Myhill-Nerod theorem method table. So we take only these green portion. Now go with our diagram. Here we see that Q0 and Q1, pair of state Q0 and Q1, check in this diagram Q0 and Q1, both state are non-final state. then we cannot mark it. Then next state is Q2, Q0. Then Q2, Q0. One state is final state and one state is non-final state. So we mark it. Then next state is Q2, Q1. Q2, Q1. In this pair of state, one state is final state and one state is non-final state. Then we mark it. Next Q3, Q0. Q3, Q0. Q3, Q0. One state is final state and one state is non-final state. So we mark it. Q3, Q1. Q3, Q1. One is final state and one is non-final state. So we mark it. Next Q3, Q2. Q3, Q2. Both states are final state. So we will not mark it. Q4, Q0. Q4, Q0. One state, both states are non-final state. So we will not mark it. Q4, Q1. Q4, Q1. Both states are non-final states. So we will not mark it. Q4, Q2. Q4, Q2. One state is final state and one state is non-final state. Q2, Q4. So we mark it. Q2, Q4. Next Q4, Q3. Q4, Q3. Q4, Q3. One state is final and one state is non-final state. So we mark it. Next Q5, Q0. Q5, Q0. One state is final, one non-final. Then we mark it. Q5, Q0. Q5, Q1. Q5, Q1. We mark it because one is final state and one is non-final state. Q5, Q2. Q5, Q2. Both are final state. So we will not mark it. Q5, Q3. Q5, Q3. Both states are final state. So we left it. Q5, Q4. Q5, Q4. One state is final state and one state is non-final state. So we mark it. So we have this diagram after step 2. Now go with step 3. In step 3, we consider the all unmarked pair of states this is unmarked pair of state, this one, this one, this one and this one. These are the unmarked pair of state. We consider these states as, now we take this transition P and X and transition Q and X. Two states should be in this diagram. There are transition, we check for Q0 and Q1, then transition for Q0, Q0 0, Q0, when state is Q0, input 0, next state is Q1. then q naught, when q naught is 1, q naught is 1, next state is q2, not same as for q1 for 0, for 0, q naught, q1 for 0, q1 for 0, we go with q naught. For transition q naught when 0, then next state is q1. When q naught is 1, next state is q2, and when q1 is 0, next state is q1 is 0, next state is q naught. When transition q1 and input symbol 1, then next state is q2. So we check here for this pair of state transition q naught 0, comma transition q naught 1, then we get with the state q naught 0 and q naught 1, we get with q1 state. When transition q naught 1, comma transition q1 0 and q1 1, q1 0, q naught and q1 1, q2, q0, q2. q2, q1, q0. Step 3, see here transition px, transition qx. So qx, q naught 0 and q1 0. We explain here for the both step again. Transition clearly q naught 0, comma transition q naught 1, then we get with q naught 0 and q naught 1, we get with q1, and same as for q1 0, comma transition q1 1, q1 0, q1 0 is q naught and q1 1 is q1 1 is q2. So we combine these states, and if we get with one state is already marked, then we marked here. If there is a marked combination of state in both pair of just q naught q2, q naught q2, we see here q naught q2, q naught q2, this one is marked, so we mark here, else left these pair of state and continue these steps until the all unmarked pairs of state will marked. Continue these steps when these unmarked pair will marked. If we at the end, if any unmarked state left, then consider that unmarked state and combine these states accordingly. Step 4, all unmarked pair PQ and make them single state in the pair. So here continue this step until these unmarked pair will marked. At the end, we left with those unmarked pair only that we consider for our minimization diagram. After these step, continue this step, we get with combination of unmarked pair of q0 q1. q0 q1 will be unmarked pair in table, q0 q1 will unmarked. So we combine these states, and unmarked pair will be in the table, q0 q2 q3 will be unmarked, q3 q5 will unmarked, q5 q2 will unmarked. So we combine all these three states. So one combined state will be this, and one combined state will this, and remaining one state is this. And we in this diagram, when combine these state, if they any pair of state have a final state, then we consider whole state as a final state. Now its minimized diagram will be like this: q0 q1 combined, q2 q3 and q5 will combine, and q4 will combine as a single state, and in this state find q2, and in this example all these three states are final, so make it a final state. And we see the input q0 q1 0 and q from q1 to q2 1. q0 we combine these states, then q from this state to this state the input is 1, so we can take it and this state is combined, then the loop will consider as a 0. And if we combine these states, the with the help of this arrow go this state, when input is 1 go with state q4 and 0 for there, 0 and 1 for loop, and the next state is q4. Now we get with minimized DFA with the help of Myhill-Nerod theorem or table filling method. Okay, thank you.